Hello students, I welcome you all to this class. This is mathematics class, and in our previous classes we have studied this topic, integration. Today we'll be looking at the application of integration. So basically we'll be considering the first part of application of integration, which is finding the area under a given curve. So from what I've written down on the board here, I say that the area bounded by the curve y is equals to f of x, and the x-axis in this closed interval a comma b, is given by this formula, integral from a to b of absolute value of f of x with respect to x. Let's consider the example we have on the board here. So we have example 1. They ask us to find the area bounded by y is equals to 2x squared, and the axis x is equals to 1 and x is equals to what? 3. So we have integral of what? Integral from a to b. So a is what? The first point of x. B is the second point of x. That's integral from 1 to 3 of absolute value of f of x. What is the f of x? F of x is given by 2x raised to power what? 2. So we are going to have 2x raised to power 2. Then we are integrating with respect to x. So we are putting this inside absolute value. We are using the formula. Now we are going to perform the integration of this integral from 1 to 3. Looking at this, we have 2x squared. So x squared cannot be what? X squared cannot be negative, because the square of any number cannot be what? Negative. And we have the interval. In the interval we are considering is from 1 to what? 3. Numbers from 1 to 3, they are all what? Positive numbers. So this 2x squared cannot be negative. And you know that absolute value of a positive quantity is that positive quantity. So absolute value of 2x squared is the same thing as 2x squared. So we have 2x squared. We are integrating this with respect to x. So this will be, we can perform the integration now. So to integrate 2x squared, we have 2x. Then you add 1 to the power. What is the power of x? 2. If you add 1 to 2, making it what? 3. Right? Then you bring down this 3 to divide. You divide by that result, 3. This is how you integrate. Then the interval is what? From 1 to 3. Evaluated from 1 to what? 3. So you put the upper value. The upper value is what? 3. You substitute for x here. X is 3, so you are going to have 2 multiplying 3 raised to power what? 3. Right? Putting x for 3 for the first, then divided by 3. I have substituted the first point, the upper point, for x. Then you are going to put minus before substituting the lower point. After putting the minus, you now substitute the lower point. The lower point is 1. You substitute for x here. So you'll be having 2 open bracket 1 raised to power 3 divided by 3. This is the result you have. So this will be equal to 3 raised to power 3 is 3 times 3 times 3. That's 27. 27 multiplied by 2, you are going to get what? You are going to get 54. So you have 54, then divided by 3. 54 divided by 3. Then minus 1 raised to power 3 is still 1. Then 1 multiplied by 2, you are going to have 2 divided by 3. So we have that the LCM we have here is what? 3. 3 is the LCM. Then we can subtract 54 minus 2. If you do 54 minus 2, you are going to have what? 52. So we have 52 divided by 3 as the final result of this integral. So this gives us the area of this curve. So we are going to have, so this will be the area of this very function, evaluated from where? From 1 to 3. So this gives us the result. So see you in our upcoming class. Bye.